So we began with something like 190 million points, and these were captured by the laser scan survey undertaken in July by UCL's Civil Engineering Geomatics Department. In Cloud Compare, we've used this to subsample this incredible data set down to, for this view, a point just every 2 meters on average across the area. So it's manageable. It runs on my PC, which has only got 16 megabytes of memory on, but you can see it's fairly smooth. But this is the area that we're actually interested in. Wayne Bay over here, the headland landscape to the south is all pretty much irrelevant for what we're doing. I've also taken out all the seagulls that were causing problems here. So from this data set, we've actually gone and cropped this further. To develop one just for the headland. So this becomes far more manageable. Again, this is a high res. I think this time I selected every 0.25 meters, so that's every quarter of a meter. You can see all the major features, the rock arch, there's the West Ravine, there's the South Stack, you've got the back of the cliff, you can even see the little hut there on top. So, you know, this is a fabulous data set, and what I want to work towards is being able to mesh this, so effectively we'll be able to 3D print it, we'll be able to recolorize it, and you can fully explore the site. You can see we have got some gaps here. This is where we didn't get coverage, and currently working on a way to at least interpolate across these gaps. But what we need to do right now is focus in on the West Ravine. This is going to be the area of interest for us. If we actually want to model this and develop contours, we don't need 3 dimensions. We just need draped surfaces. But if working with draped surfaces, digital terrain models, which are 2.5D surfaces, these create some problems because of course we've got all of this 3-dimensional geometry. We've got the arch here, you can see how the southwest stack overhangs. If you're trying to interpolate down from the top, this is going to cause a lot of problems. This is going to cause the grid to effectively start on the highest point for any XY coordinate rather than the surface we're on. So we needed to crop even further, and I've got some examples of these coming up. So one of the first things I wanted to do was develop, I'll go back here actually, a version of this file without the arch and without the stack. So you can see here I've effectively decapitated the headland, slicing through it, but preserving the detail of the West Ravine. So if we zoom in here, you can see these problems of overhang here in the West Ravine, and largely in this data set the problems of overhang here in the North Ravine have gone, but there's still some issues. We've got a bit of overhang here, a bit of overhang here, and if you look here, this is really annoying. There's this ancient, I think, wave cut notch here, which means this entire surface here overhangs, and that's going to be a bit more tricky. We just focus in, you can see we've still at this 0.25 resolution got enough information here in the West Ravine. We can see the large boulder here that blocks the West Ravine, this smaller boulder, and the details of the slope at the back of the West Ravine. But there's a lot of data here we don't need, so we go even further. West Ravine dataset. Got a lot of files here. And here we've taken everything else out, so you can still see I've got a cropped data set. I've cropped it even further. Not cleaned up at the moment, but we just are focusing in on that area of interest. Now the next thing I wanted to do was actually take this into another program called Surfer, where I can actually generate the contours. But for this I needed to do something about these areas that are blank, because these would end up trying to interpolate across in crazy ways. So we use Cloud Compare then to produce a grid file which actually interpolates across. This is probably the best one to show. And you can see here those areas have been completely flattened. So it's then possible to take this grid file into Surfer. I'll just open up a blank file in Surfer. Take that grid directly and produce from that a contour plot. And then from this contour plot we can do neat things like develop profiles for engineering. If we wanted to, even within this format, we can develop our own models. I'll go into here, just scale this up. And we got another way of developing a sort of digital terrain model of the inside of that cave. So what we have here now, finally, through the help of this laser scan, which we've been sort of waiting for this quality of data now for sort of 5 years, is a way of complete control over visualizing the cave as it currently stands, from this reconstructing how it may have looked in the past, and more importantly, is sort of informing management decisions and engineering decisions as we go forward protecting and investigating the site in the future. So it's been a mammoth undertaking trying to capture this Neandertal mega site, but we're kind of there. We've got it on disk.